Okay, hello guys, and welcome to my channel. Now in this video I want to talk about the properties of rational exponent, right? So you look at these 6 properties here, they look very abstract, right? Don't worry, we're going to simplify them for you with examples for each of them. Okay, so we start with the first one. When we have the nth root of a, it can be square root of a, fourth root of a, where a here is just a number, okay, and a is said to be 0. Okay, so if you have a to be 0 as an input, then you have to take the root, a certain root of that 0. The result will be 0 for whatever n you take. For example, when we have the square root of 0, it is 0. When we have the cube root of 0, it is still 0. Fourth root, fifth root, sixth root, okay, so for any positive integer n, which is greater than 1, as we discussed earlier, we say that when 0 is the entry, okay, then if you evaluate it, it's going to give you 0. Okay, so that's for the first one. Now for the second one, we see here that the nth root, which could be square root, okay, fourth root and so on, cube root, okay, the nth root of a certain number a will be b if, now, this b is a positive real number. This a is any number that is also positive. Look at this. If a is greater than 0, alright? And then, okay, if a is greater than 0 and b is a positive real number, that means b is also greater than 0. Alright? That is b is a positive real number. Now, this certain property is telling us that when we have the nth root of a certain positive number, alright, then the results will be another positive number. Okay, so for example, when we have, let's talk about the square root, okay, when we have the square root of, let's say a certain positive number 4, so you see that here is just n, okay, since you're dealing with square 2, we don't have to indicate it as we discussed earlier, right? This right here will give us another positive number, which is what? 2. Okay, great. When we have the cube root of, let's say, cube root, that is, I've put down the 3 there, let's say 125, 125, this right here gives us 5 as a result, alright? You know, the cube root of 125 is 5. Now, when we have that b, this b is going to be a number such that when you say b raised to power n, it is going to give you back that a. So the result raised to power n, which is the index, it will give you what is here. So this means that if we have 5 raised to the power here, that is 3, this right here is going to give us 125. So it means that the cube root of 125 will be equal to 5, because 5 raised to the power of 3 is 125. The same thing is applicable to this first one. When we have the square root of 4, it is going to be 2, because 2 raised to the power of 2 here, now this index is going to give us 4. So that is how we get it, alright? Okay, very nice. Now for the third property, we see that if a is a certain positive number, that is a is greater than 0. Now, when we have a number greater than 0, if you multiply that number by -1 or by any negative number, the result will be less than 0. That is, the result to become negative. For example, you have 2, and you multiply 2 with -1, the result is going to be -2. That means you're just having a negative result, alright? So if you multiply a certain positive number by -1, or any negative number, the result is going to be negative. You know, positive times negative is going to be negative. Okay, great. So because of that, we're just going to apply that to the third property here. We see that if a is greater than 0, it means that negative a will now be less than 0. Okay, great. And the same thing is for b, that if b is greater than 0, it means that negative b is less than 0. Now we are going to use these two guys and put them here and see what we are talking about. Negative a is less than 0. Now, if you take the nth root of a negative number, okay, it is going to give you a negative result, provided that this n here in the index is an odd number. So this will give us a negative result, provided n is odd. Now, for example, when we have I'm going to construct an example that will satisfy all these. The index here, the input here should be negative, and the index here should be an odd number. For example, when we have 3 in the index, that is an odd number, right? You know, odd numbers 3, 5, 7, 9, and so on, which are not divisible by 2. And when we are considering index like this, we consider it to be a positive integer. So we are not going to talk about the negative numbers, all right? So this is going to be 3. Then I'm going to put in a negative number in this form, like negative 27. So the cube root of negative 27, this right here is going to give us negative 3. Reason being that, let me just put because, negative 3 raised to the power of this index, 3, is going to give us negative 27. So that is why we are saying that the cube root of negative 27 is negative 3. And if you want to observe from the statement here, we are saying when n is odd, that is the index, okay? And it means that negative b, which is the result, which is actually a negative number, because b is positive, negative b is negative, is going to be less than 0. So the result here is negative, and then negative b raised to power n is going to give you negative a. Maybe I just use another example to show this. When we have the cube root of 125, alright, this right here is going to give us negative 5, because negative 5 raised to the power of the index here, 3, is going to be negative 125, right? Sorry, I wanted to put down negative here, alright? That is negative 125. It's going to give us negative 125. Okay, so that is it for the third property. Maybe just clean this up and we enter for the fourth property, alright? And now in the property number 4, we see that when we have, now in this case it's going to be a little bit different, the nth root of a raised to power n, that is to say, if, for example, you take the cube root of a certain number and you raise that number to power 3, so the nth root, so the cube root of 2 to power 3, you know what we do? We just say that the power will cancel the root, alright, because they have the same indexes. Okay, great. So that is what we are saying here, that when we have the nth root of a to power n, the result will be a, that is, it will just come out, we cancel, I'll use this one to cancel this one, this will just give us 2, alright, very nice. But that does not always work out all the time. Now this is it. This will be equal to a, which is just the input 2, if the input is either greater than 0 or equal to 0. That is to say, for example, if we have the fifth root of 0 raised to the power of 5, this is just going to be 0 because the input is 0. Okay, so whatever input it is, provided it is greater than 0 or equal to 0, the result is going to give you that result. That is what this statement is saying. Whatever you put here, okay, provided it is greater than or equal to 0, you are just going to get it out. So if you put in, let's say, we put in fourth root of 16, okay, and then, okay, let me not use 16, let me use 2 so that it will rhyme, right? 2 raised to the power 4, okay, you know this is an index and the same thing here with the power, and this 2 is just a number greater than 0, so it satisfies. This right here will just give us the 2, okay, very nice. So that works out very fine for the number 4 property. Now for property number 5, we see that when we have the nth root of a certain negative number, now, okay, this is negative a, so let's take it to be a negative number. We raise it to power n, alright, nth root power n, but this is for a negative number. This right here will give us a negative result. That is a negative, that negative number you input it. If n, the index, and the power, if it is an odd number. Okay, so I'm saying that negative a is less than 0. That means negative a is a negative number, right? It is not positive. So there are cases where we have negative a to be positive. If a is less than 0, then negative a will be greater than 0. But if a is greater than 0, then negative a will be less than 0. So that is why I'm putting that condition. So for the number 5 property, we see something very nice, alright? That whenever we have a certain expression where the index is an odd number, right? That n, if n is odd. So let me just put any odd number for you. Let me just put down 3. Okay, I don't want to go for bigger odd numbers because it will require bigger entries. Then we enter with a negative number. So I can just enter with, which negative number can we think of? Okay, let me just put down negative 8. Okay, let me not use negative 8 because I'm going to raise it. Okay, let me put down negative 2. Okay, that is negative a. So let's take a to be 2. Then negative a will now be negative 2, which is less than 0, right? And we raise that to that same index, that is raise that to power 3. So we raise it, that means I raise everything here to power 3. That this right here is going to output that negative number. Now if you look at this, negative 2 raised to the power of 3 is negative 8. And the cube root of negative 8 is negative 2. So this right here will just give us negative 2. Just like saying you want to cancel this with this. Now, this only works out when you are talking about odd index and power. That is the same, but they are odd. Okay, they are not even. If they are even, it's going to complicate our work. Reason being that if you want to take the square root, for example, which is even, the square root of a negative number will not exist in the set of real numbers. So we will be very careful with what we have. Okay, so this is applicable, and you have to be careful whether it is an even power or whether it is an odd power, right? That is in terms of the root. Okay, so that is just it for the number 5, and the number 6 is even where we are, what we were saying earlier. Here we are having n, okay, the nth root of negative number raised to power n. This will give us these two strokes and the a inside without the negative. Now, in fact, let me do this. This will give us the two strokes and then the negative number. Okay, for example, when we have, now this will work out if n is an even number, okay? So when we have an even input, let me show you that it is even by just using 4th root. Okay, when we have the 4th root of, we put in a negative number, let me put down negative 81. Okay, I raise it to the same power here, which is 4. Okay, so we are saying that this is going to be, well, I would like to rewrite this in another form before I actually put that. This is going to be the same thing as 4th root, okay, of negative 81. Then I raise it to power 4. I hope you remember this when we were talking about rational exponents, that when we have it inside, we can also take the power outside. Okay, so they are the same thing, actually. Now, when we have a negative input here, raise it to power 4, and then you take the 4th root, it's like taking the 4th root of that negative input and raising it to power 4. But we learned earlier that the even root, 4th root, square root, 6th root of a negative number is not a real number. So that is a big problem right now, alright? Well, this property number 6 has a solution for that. It says that when we have such situation, we will put it down as absolute value. These two strokes is actually an absolute value of the entry, which is the negative a, okay, if this was the negative a. Now, what this absolute value will do is it will just take the entry, provided that the index here and the power here are the same, so it will be negative 81, alright? Now, this absolute value will give you a positive result. So this is just going to be 81. Now, absolute value evaluates to positive whatever you put into it. So if you put in a positive number, it will still output that same positive number, which is the identity. But if you put in a negative number, it will make sure it is positive, alright? For example, absolute value of negative 2, it is going to be 2. Absolute value of 2, it is going to be 2. But the absolute value of 0 is going to be 0. So it will just output whatever you put for it when it is either 0 or a number bigger than 0. Or if it is a number less than 0, then it's going to give you the positive of that number. Okay, great. So that is just more about it. I believe you understand this. You can apply this in lots of examples when you'll be solving them. Okay, this is a nice place to end the video, and that was for you, so please subscribe to my channel.